channel. So we have a question here: effective nuclear charge for 3D electron in vanadium according to Slater's rule. We have this question here. We have to find the effective nuclear charge. So according to Slater's rule, he gave a formula that is called as Z star or Z effective is equals to Z minus sigma, where sigma is the Slater's constant. It is a constant, and what it basically means is how much effective nuclear charge means how much attraction electrons revolving around an orbit get attracted, by which force it gets attracted toward the nucleus. We have to find the force, the net charge. Okay, so this is Z star and this is equals to Z minus sigma where Z is the atomic number and sigma is the Slater's constant. And for this you have to remember, if the number of if the last shell, if the valence shell or last shell is n, we have to multiply all the electrons by a number 0.35, and all the electrons present in the n minus 1 shell we have to multiply it by 0.85, and all the electrons in the much lower shell we have to multiply it by 1. So this you have to remember for doing such questions. This is 85. Okay, so we take example. For example, we have to calculate the for the 3D electrons. First you need to know the configuration. Without knowing the electronic configuration you can't solve this such question. So electronic configuration for 23, for Z is equals to 23, you have to find out what we know that it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d3. This is the electronic configuration. Okay, you can count it 2 to 4, 4 or 6, 10, 10 to 12, 12, 6, 18, 18 to 20, 20 plus 3, 23. We have getting 23. So this is the entire electronic configuration. It means what? We have around 4 shells. Got it? Imagine like this, 4D, 4s2 and 3d3 must lie somewhere here. Okay, so electrons present in this shell 3d3, we have to take any one electrons. We know if this is the 3d shell, there must be 3 electrons present. We can count, take any one electron into account, and we have to calculate the net repulsion felt by this electron by the inner electrons. Okay, there must be 8 electrons here, 8 electrons here, and 2 electrons here, and 2 electrons here. So you know the electrons inside the shell repel, gives a repulsive force towards these electrons. Okay, similarly the inner shell also gives electron. The more inside you go, the force will, repulsive force will become. That's why the constant is also increasing, as you can see. For this you know that the valence shell is 4s2. It means 4 shell is our n. Okay, n is equals to 4. So n is equals to, यहाँ पर 4 हो जाएगा, n minus 1 is 3, the third shell here, and n minus 2 any 2 shell here, and for first shell 2 electrons here, we have to take that is also as 1. Okay, so we have to calculate the sigma because we already know the Z. We have to calculate the effective nuclear charge Z star. For that we need Z and sigma. We already know the Z is 23, but we don't know what is the sigma. Okay, so we have to calculate. So for calculating this sigma or effective repulsive forces, you can say shielding or power also said, someone says. So for the sigma we have to take into account all the electrons present inside which are giving the repulsive force toward these electrons, So for the electrons present in the, we are taking this electron into account. It means it will feel some repulsive force or shielding force from these 2 electrons also. So we will take these 2 electrons. Okay, and 2 electrons into n is what? 0.35, because we are assuming that here n is our fourth. Okay, the electrons present in the fourth shell. So 2 into 0.35 plus we have to also take this 4s electrons. Take 4s electrons. So 2 electrons from there into 0.35, or you can say that 2 plus 2, 4 electrons. Directly you can like this as 4 into 0.35, because this one electron will feel a slight force from the electrons present in the 4 shells only. Okay, The inner we go, the repulsive forces will increase because they will shield very effectively. So the constant, as you can see, is also increasing. So for the electrons present inside the cell, for example, in the n-1 cell, n-1 cell means 3s cell, we have through 2 plus 6, 8 electrons. Okay, so we'll multiply 8 into 0 0.85, 0 0.85 plus we know that we have 8 electrons in the 2 cells also, so 2 means 1, so 2 multiplied by 8 multiplied by 1, and we have one more electron in the 1s cell out, so we have to calculate 2 into 1 also, so plus 2 into 1. So we will, by calculating all this, we will get 4 into 0 0.35 around 1.4 here, around 7 here, 8 into 1 plus 2, so we will get around 8 to 10, 17, 17 and 18.4. So here is our sigma. Okay, so for calculating the z star, we will simply what do, apply the formula z minus sigma, where z is 23 as you know, and sigma is 18.4. So we will get around 4.5 or 4.6, around you will get this answer. Okay, so this is our answer. This question was asked in the IIT JAM. So here is the answer, z star. This is what sigma, and this is our z star. This is the answer. Got it?